Hi, this is Tim. In this video, we're going to start working with our linear motion control trainer. And before we even start, I want to talk about the linear actuator that I selected, because when I was asked to build this trainer, really the only requirement I was given was that it had to tightly integrate with Allen Bradley's Contrologix and Compactlogix PLC. And based off of that, you would think one of the kinetic servos would be the best choice. But what I actually found out was that this Yamaha setup integrated easier with Allen Bradley than the kinetics actually did. Another thing I liked about it was, compared to a lot of linear, we'll say selection guides, where you have to give it like 200 parameters for it to manage to select an actuator, motor, and all that stuff. In this case, all I had to do was tell Yamaha that I wanted to travel this distance over a certain amount of time, and this will be my load, which in our case, the load is virtually nothing. And even then, I ended up telling them, like, okay, I need actually to know an actuator that will fit across this plate. Can you back figure all that for me? And they did, and really with one part number, I got the linear actuator, I got the motor, and on the back side here, we have our servo drop. So with this one single part number, I've managed to select everything I need, as opposed to having to select an actuator, a coupling, an adapter, a motor, a servo drive, cables, and on and on. Really, that single part number, it came in and everything was here. So I'll put a link to this trainer down in the description. And in this video, really, we're going to go through just wiring enough of it to get started, which is mostly going to be on the back side. And we're going to wire our Allen Bradley Compactlogix PLC with a few additions that I think we're going to need in this video. Go to TW Controls and let's find the standard drawings. And then we're going to be looking at this TRN-BAS-5000. This is our basic wiring diagram. And on page 2, you're going to see the wiring of our inputs and outputs. So we're going to wire button 1 to input 0, button 2 to input 1, button 3 to input 2, button 4 to input 3, switch 1 to input 4, and then we're going to add a few additional ones here. We're going to go ahead and add switch 2 to input 5, and then switch 3 to input 6 and 7, because it is a 2-position selector switch. And while we're at it, let's go ahead and wire switch 4 to input 8 and 9. And then on our output side, it's going to be exactly the same as our getting started guide. So the first thing I'm going to do is I'm going to jumper the normally open a button 1, 2, 3, and 4, and all of the other switch contacts together and connect them to the plus 24 volt. Now I have jumpers actually from every normally open contact. So I'm excluding the normally closed contacts of buttons 1 through 4. And then I'm going to take that wire that is jumpered to everything, and I'm going to go to the plus 24 volt, which is the left set of terminal blocks on the trainer. Just to recap, this left section here is the plus 24 volt, and this right section is the 0 volt. And now I'm going to connect a wire to the bottom of each of those contacts. Now I'm going to land each of those wires to the respective inputs. So if we look here, we're going to start with button 1 and just run across. So button 1 is going to be input 0, and we're just going to respectively keep going across. So here's button 1. I'm going to put it into input 0. Here is button 2. It's going to go into input 1. Here is button 3. It's going to go into input 2. Here's button 4. It's going to go into input 3. And then we have switch 1. It goes into input 4. Switch 2 is going to go into input 5. And then the left side of switch 3 is going to go into input 6. The right side of switch 3 is going to go into input 7. The left side of switch 4 is going to go into input 8. But pay attention to your terminal blocks here. Your last two are not inputs. So input 8 is at the top of the second row. And then the right side of switch 4 is going to go to input 9. Okay, now we're going to wire outputs. And I'm going to start with our common, similar to what I did on our inputs, is I am going to jumper one side of each of our lights, and it is going to go to the 0 volt or the DC minus. And these lights do not have a particular polarity, so you can choose whichever one you want. I'm going to choose the right side to be my common. I have the right side of the 4 lights all jumpered together, and I'm going to take that wire and go to the 0 volt terminal block. And now I'm going to connect a wire to each of the left sides. Now I'm going to take light 1's wire and I'm going to connect it to output 0. I'm going to take the light 2's wire, connect it to output 1. Take light 3's wire, connect it to output 2. And I'm going to take light 4's wire and connect it to output 3. Now there's 2 more important connections that often get overlooked when people are doing this, is we also have this FP plus and FP minus terminal. From the factory, our trainers come with the VDC plus and VDC minus already wired up, but the FP plus and FP minus are different depending on exactly what you're doing. So in this case, we want to take FP plus to the DC plus, or the left set of terminal blocks, and we want to take FP minus to the DC minus, or the right set of terminal blocks. Okay, so that gets all of our buttons and lights wired to our PLC. And now we need to do some wiring to our Yamaha servo drive. Or actually we don't. And that's what I really loved about this is completely controlled over Ethernet by the Compactlogix. So we have an Ethernet switch right here. It already has our PLC and our servo drive connected to it. And that is all the wiring that is necessary to interface those two. Now we do have an EStop circuit that is this bottom connector here. It already comes factory wired to this relay through our red mushroom button here. So let's go ahead and power up the trainer and make sure everything works. Let's start with a new copy of Studio 5000, and we have a 1769 L16ER-BB1B, and we'll call this our linear actuator. And then, most importantly, we need to select the number of expansion modules. And we do have one expansion module for a 4 to 20 milliamp analog input on this trainer, which I guess I didn't mention that earlier. Let me spin this trainer around. And in addition to our linear actuator, which is super accurate positioning, we also do have a 4 to 20 milliamp distance sensor here, just so we can train some on 4 to 20 milliamp signals while we're at this. It's completely unnecessary if you're using a servo position control such as this, but I thought it added a little bit more interaction for training purposes. So we'll select one module and finish. And we're just going to download that program just as it is. And our trainer by default has an IP address of 192.168.1.10. And if you need any help downloading your program, or if I went too fast through that, or you're not sure how to configure drivers, look down in the description. We have lessons on all of that. And we're going to select run mode. And yeah, we're mainly going to use this just to test our I/O. So I'm going to open up our controller tags, and we're going to open up our local input. We're going to go into the data. And I'm going to press button 1, input 0 lights up, button 2, input 1 lights up, button 3, input 2 lights up, button 4, input 3 lights up, switch 1 to the right, input 4 lights up, switch 2 to the right, input 5 lights up, switch 3 to the left, input 6 lights up, switch 3 to the right, input 7 lights up, switch 4 to the left, input 8 lights up, and switch 4 to the right, input 9 lights up. So that takes care of our inputs, but while we're here, let's go ahead and label these. This is button 1, button 2, button 3, button 4, switch 1, switch 2, switch 3 to the left, switch 3 to the right, switch 4 to the left, switch 4 to the right. Okay, now let's go ahead and test our outputs. And so since nothing is writing to our outputs right now, we can put a 1 in each one of these and make sure they work. I am going to put a 1 into the value of output 0. Notice I'm not messing with this force mask here. You'll rarely see me use the force mask in videos. So I'm going to put a 1 here, and our green light comes on. Change that back to a 0, and I'll put a 1 in output 1, and the yellow light comes on. Put it back at a 0. I'll put a 1 in output 2. Red light comes on. And I'll put a 1 in output 3. And the blue light comes on. So all of our outputs work as well. And we'll go ahead and label them while we're here. This is going to be the green light. This is going to be the yellow light. This is going to be the red light. And this is going to be the blue light. So that covers testing all of our inputs and outputs coming to our buttons. There's one other thing we want to test. We do want to test this EStop right here. So I'm going to spin the trainer back around. And to the right of our servo motor, we do have this relay. And also we do have an error light up here. And we should see a red blinking light here and this green light go out when we press our red mushroom button. And now I have a red blinking error light. And yeah, the green light is out here. Pull it back out, and the red blinking light goes away on our servo drive, and our green light comes back on. So we've tested all of our discrete I/O now, and we do have one more thing to hook up, and that is going to be the analog sensor. So on the front of our trainer, we have this analog distance sensor that is sensing where our servo is at. And on the back side of our trainer, beside our plus and minus 24 volt, you see two sets of single row terminals grouped together. The first set is the analog signal to our display meter up here. And the second set is from that analog sensor. And you're going to see one wire jumpered from the left terminal of our analog sensor to the middle terminal of the meter. And what that's allowing us to do is right now it's showing 15.2 milliamps. And if we just move this a little bit, you're going to see that value change. And that's because this milliamp signal changes as this moves. In fact, you can just stick your finger in here and you can see that value change. Well, we want to connect that to our PLC now. So what we're going to do is take the factory installed jumper wire off of that middle terminal going up to our display meter. And we want to connect it to channel 0. And that is going to be the top left terminal on that. So we'll connect it. And we're done. So in a little over 30 minutes, we've managed to wire all of our inputs, all of our outputs, and our analog. And we're ready to start writing some program to interface our Allen Bradley Compactlogix PLC to our Yamaha TS-SH servo drive. So in the next video, we will start adding it into our I/O configuration and go through the first steps of getting our servo moving. So if this video has been helpful, I'll put a link to this trainer down in the description. Till next time. Hi, this is Tim.
And this is Amber with TW Controls. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like these.
When you're ready for some intense PLC training, check out our PLC lab.
And if our videos have helped you out and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya.